Dear students, in this video lecture, we are going to discuss the topic feature extraction. Feature extraction. We know that for a data set, we are having a large number of features. From that, we have to consider only the relevant ones for our problem. So that feature extraction is introduced, and this will be happened in two stages: feature selection and feature reduction. Feature selection is the first stage in feature extraction process. And in case of feature selection, what is actually happening is we are trying to extract a subset of features from the original dataset. We know that for a dataset we are having multiple attributes. From that, we have to select the most appropriate attributes to our model training. So in a data set, the features are stored as vectors. Feature vector is an n-dimensional vector, and if the dimension of the features is high, model is accurate and have high frequency. But the time complexity of the model increases. So in order to reduce this time complexity, feature selection is used. Feature selection is actually a subset selection of existing features, and this can be done through genetic algorithms. Feature selection is also known as variable selection or variable subset selection, and this is the first step to select a subset of features from the existing dataset and store them as feature vector. For this particular feature selection, genetic algorithms are used to select the appropriate features. Then another important point related to this feature selection is feature selection reduces the number of resources. Selected features contain only relevant features which are used for model construction. Feature extraction creates new features from functions of the original features and results in small and rich set of attributes. So this feature selection actually help to reduce the total amount of resources, and the same thing it will only select only the relevant information which are used for model construction. And this particular feature extraction, it create new features by using functions in the original features, so that new features can also be created. And the output of this feature extraction is it will produces a small and rich set of attributes. Now we will see the advantages of feature selection. Learning process becomes faster because we are trying to remove the unwanted features, and we are only considering the most appropriate ones. Reduces the time complexity, performance increases, reduces overfitting, shortening training time, improves the accuracy of the model if the right subset is chosen. Then simplification of models to make them easier to interpret by researchers or users. So in feature selection, what is actually happening is from the original dataset we are trying to extract a subset of the features, and for model construction we are only considering this subset of features, so that learning process will become faster since the size of the features reduces. The time complexity also reduces and its performance increases, and it also considers the problem that arises due to noise data. Then since the corresponding subset is having reduced features, the training time can be reduced. At the same time, it will improve the accuracy of the model. Feature selection is actually we are trying to extract a subset of features from the original dataset, and this feature selection can be done in three different strategies. These three strategies are used for doing the feature selection: filter method, wrapper method, and embedded method. We will discuss all these methods one by one. Now move on to the filter method. Is one of the strategy for feature selection. It assigns a score to each feature by using some statistical measure, and it is also known as pre-processing module. The selection of the feature is independent of machine learning algorithm. Here the features are ranked by the score, and based on the score it can be either to be kept or removed from the dataset. The methods are of univariate and consider each feature independently or with regard to the dependent variable. So in filter method, it assign using a statistical measure, it score each feature, and depending upon the rank of the score, the feature can be either added or removed from the data set. This is the basics of filter method. First, we are having a set of all features, that is the original data set. From the original data set, we are selecting the best subset. And for selecting the best subset, we are using some statistical measures. And based on the subset, we are trying to create a model using some machine learning algorithms. And finally, we are evaluating the performance of the model using some performance measures. Now we will see how we can select the particular subset. In filter method, we are assigning a score to each feature by using some statistical measures. Now we will see what are the statistical measures. For continuous type of data, we are using Pearson's correlation coefficient. Pearson's correlation coefficient, and it is termed as LD. For continuous variable, we are using Pearson's correlation, and for categorical variable, we are using LDA, linear discrimination analysis, and it is a linear combination of feature that characterizes or separates two or more classes. Then if the feature is categorical, we are using ANOVA. ANOVA means it is a statistical test of whether the mean of several groups are equal or not. Then chi-square test is used for categorical variables. It evaluates the likelihood of correlation or association between them using frequency distribution. Here we can see the statistical measures which are used in filter method. First is Pearson's correlation. It's also termed as Pearson's correlation coefficient. It is used as a measure for quantifying linear dependence between two continuous variables x and y. This Pearson's correlation coefficient is normally denoted by the letter rho. Rho of xy can be calculated as covariance of xy divided by sigma x into sigma y. So the resultant value of rho should lie between -1 to +1. -1 means negative correlation, +1 means positive correlation, and 0 means there will be no relationship between these two variables. Negative value represents a negative correlation, and positive value represents a strong correlation. The another important statistical measure is LDA, that is linear discriminant analysis. It is a linear combination of features that characterizes or separates two or more classes, and it can be used for categorical variables. ANOVA is another statistical measure which is used for feature selection, and it is termed as analysis of variance. So it is a statistical test of whether the means of several groups are equal or not, and this is actually a testing quantity or testing measure. Then another last statistical measure is chi-square test, and it's a statistical test which evaluates the likelihood of correlation or association between two or more variables using the frequency distribution. It's also used for categorical features. So these are the measures, statistical measures, which are used for feature selection by using the filtering method. The second strategy for feature selection is wrapper method. In this wrapper method, we try to use a subset of features and train a model using them. For this, we are using either forward selection or backward feature elimination. So what is actually happening in wrapper method is, here in wrapper method we are trying to use a subset of features and train a model using them, and this feature selection should be happened in two methods, forward selection or backward feature elimination. So this is the set of all features. From the set of all features, we are generating a subset. Based on the subset, we are training a particular model using a machine learning algorithm, and finally we evaluate the performance. But in wrapper method, we are using two methods are used for selecting this subset: forward selection and backward feature elimination. In forward feature selection strategy, we select one variable and analyze the performance of model by adding another variable. Here the selection of variable is based on higher improvement in model performance. So in this forward feature selection, we actually start the model with no features. In the first iteration, we select one variable and analyze the performance of the model. In the second iteration, we add one more feature and again analyze the performance of the model. If the performance of the model improves, we stick on with these two features and we proceed the iterations. So in each iteration, we add one feature to the existing features and we analyze the model performance. If the model performance improves, we keep that particular variable in the subset. Otherwise, we remove or we discard that particular feature from the model. Backward feature elimination is just opposite as that of forward feature selection. In backward feature elimination, we start with all the features and remove the least significant feature in every iteration, which improves the performance of the model. We repeat this until no improvement is observed on removal of features. So in backward feature elimination, we start with all the features, remove the least significant feature in every iteration, which improves the performance of the model. Repeat this until no improvement is observed and removal of the corresponding features. So this is all about the backward feature elimination. In backward feature elimination, we create the model with all the features on the data set, and from that particular model, we are trying to remove one attribute, one least significant attribute. Then we check the performance. If the performance improves, we try to eliminate the next variable, next least significant feature. Likewise, we remove all the irrelevant features from the data set so that the performance of the model improves. And this process continues until there will be no change happened in the performance of the system. The third strategy used for feature selection is embedded method. It combines the qualities of both filter and wrapper methods. So embedded methods learn which features best contribute to the accuracy of the model while the model is being created. And the most common type of embedded feature selection are regularization methods, lasso and ridge regression. So here in embedded method, it combines the qualities of filter method and wrapper method. In this particular embedded method, learning happens by analyzing which features best contribute to the accuracy of the model Some of the regularization methods like lasso and ridge regression are used. So this is a general diagram related to embedded method. We are having the set of all features. We generate a subset, and using that subset we learning algorithm. The performance of learning algorithm is evaluated, and based on the evaluation again we create a new best subset. Likewise the process continues. So this is all about the embedded method. So just remember about embedded method as a combination of both filter and wrapper methods. So hope you understood all the methodologies which are used for feature selection. Thank you.